functions. A function is when each input value, or x, is paired with only one output value, or y. To demonstrate this, I'm going to use two real-world examples, one to show a function and one to show an example that is not a function. This is my car key. When I take my car key out into the parking lot, my key only works inside one car, the car that belongs to me. Even if there's another car that looks exactly like mine in the parking lot, my key will not work inside of it. This is an example of a function. When I get dressed in the morning, I pick out a shirt, and my shirt can match with jeans, a pair of shorts, and a skirt. Since my shirt can go with many different types of bottoms, this is not a function. If you think about the key being the x and the cars in the parking lot being y's, since the key x can only go with one car y, it's a function. So each x has one y pair. In the situation with the clothes, the shirt is the x, the bottoms are the y. Since the shirt x can go with many different bottoms or y's, not a function. So x is paired with more than one y. You can think of a function as having the input. You put that input into the rule, and then out comes the output. Well, what you're putting in is the x value, and you're putting that into the equation. You work it all out, and you end up with the output of a y. You can plug in anything you want for x. X is the independent variable. And depending on what you put in for x and plug it into the equation or the rule, you get your output of y. So y is the dependent variable. So there's three different ways you're going to determine if you have a function. One of the ways is by looking at a list of ordered pairs called a relation. When you have a list of ordered pairs, the x values are the domain and the y values are the range. So here we're just given a list of ordered pairs, and we need to determine if this relation is a function, and then we're going to state the domain and range. So to determine if this is a function, we have to look at each x value and see if it is paired with more than one y. -2 is paired with 3. And as I look at the other ordered pairs, there's no other -2 in the x position, so -2 is only being paired with 3. -1 is paired with 4. There's no other -1s, so -1 is only with 4. 0 is paired with 3. There's no other 0, so 0 is only paired with 3. 1 is paired with 5. And when I take a look, I also see here that 1 is paired with 6. So this is not a function. And the reason being, 1 is paired with 5 and 6. You need to be specific. An x has more than one y pair, and that x value is 1, and it's being paired with 5 and 6. So we can have the list of ordered pairs. We could be given a table for our relation. So again, determine, I need to go back, I jumped ahead. We need to state the domain and the range. So domain are the x values. So you just list all the x values you see. -2, -1, 0, 1. You do not need to repeat the 1 that is twice. And the range are the y values. 3, 4, there's 3 again, 5, and 6. So our next relation is given in a table. So start with -8. -8 is paired with -22, and that's the only thing -8 is paired with. -6 is paired with -16, and that's it. -4 with -10, -2 with -4, and 0 with 2. So since each x has one y pair, this one is a function. Okay, and state the domain and range. Domain are the x values, -8, -6, -4, -2, 0, and range, -22, -16, -10, -4, and 2. The third way you can be given a relation is from a mapping diagram. In the mapping diagram, we have all of our x values and all of the y values. And the arrows tell you which x, tells you the x and how it's paired with a y. So -2 is paired with 8, -1 is paired with 2, 0 is paired with 0, 1 is paired with 2, and 2 is paired with 8. Since each one of those x values is only paired with one y, this is a function. In a mapping diagram, you can tell that it is not a function if there's two arrows coming from one x value. It doesn't matter that both -1 and 1 are paired with 2. It doesn't matter that the y is repeating. It matters that each x is only paired with one y. So domain and range, when you have a mapping diagram, is pretty easy. You just write the numbers in the x map for domain. So -2, -1, 0, 1, and 2. And the range is the y, 0, 2, and 8. You can also determine if a relation is a function if it's given to you as a graph. When looking at a graph, you can determine if it is a function by using the vertical line test, or VLT. Well, it's a test. It's either going to pass or it's going to fail. If a vertical line touches the graph in one place, it is a function, so that would be a pass. And then if a vertical line touches the graph in more than one place, it is not a function, so that would be a fail. This vertical line that I'm talking about only refers to the line on the graph, not the x and y axis. So when we look at this graph of a linear function, I'm going to draw a vertical line. And my vertical line touches this graph in only one position. No matter where I could draw a vertical line on this graph, it's only going to touch in one place. So this is a function, and your reason, it passed the vertical line test. And for our last function, for our last graph, we can see when we draw a vertical line, this time it touches the graph in two places. So when it touches in more than one place, it is not a function. And your reason would be that it failed the vertical line test. You want to make sure when you draw that vertical line, you put it in a place that it can fail if it is going to. If I had drawn that vertical line right here, it would only touch in one place, and that would not be an accurate representation of the test. So always make sure you draw the line in a place where if it can touch in more than one place, you draw it there.